Assalamu alaikum. Welcome to Daily LeetCode. Today we are solving 135 candy. This is a question from top interview, a 150 questions list. We will be solving all of them inshallah. And this one, in this video, I decided to make it more interactive. So we will divide this video to 5 parts. Firstly, you will, like both of us, if you are planning to solve LeetCode, you can do it together with me in this live stream. So we will firstly analyze the problem for 10 minutes and then come up with some solutions, ideation part for 10 minutes, and then coding and testing. And after each part, there will be a recap where I will be giving my own answers to each part. But other than that, I will just mute myself and you will have 10 minutes to read, 10 minutes to analyze, and 10 minutes to solve on yourself. Okay, let's get started. The first part, understanding the problem. And our timer starts now. Good luck. Okay, now it's time to recap. I hope you could understand the question within the time frame. If not, we will recap right now. So we have this question. There are n children standing in a line. Each child is assigned their rating value given in the integer array ratings. You are given candies to each children subject to the following requirements. Each child must have at least one candy, and children with a higher rating get more candies than their neighbors.
Okay, now it's time to recap. I hope you could...
Time is... Sorry for that. We will continue. Oops. Okay. Return the minimum number of candies you need to have to distribute the candies to children. There are some examples, and as always, I have written my input and output cases. First, I defined like our input is a list of integers. Do this. The first thing you do in the interview should be clarifying input and output cases. Input is list of integers, as shown here and as given in the description. And output is the number of candies, is an integer. And we also, I just, let me write it. This was this, and here we have the example cases from the example 1 and example 2. Output is 5, ratings are 1, 0, and 2. I try to come up with the ending answer. Is it like I will try to come up with an array, meaning that for each children, how many candies are we giving? Like the first child is getting 2 candies, the second one is getting 1 candy, and the third one is getting 1 candy. I believe I did something wrong here. It should actually be 2, according to the example, because 0 is bigger than is less than 2. Therefore, this one should get more candies than this child. And we have another example given here, and I also tried to come up write the input output array for the case. So children are 1, 2, 2, and the allocation is 1, 2, and 1. And here it says, here is the tricky part. The third child gets 1 candy because it satisfies the above 2 conditions, meaning that the first condition is the third children has at least 1 candy, and it's not it does not have higher rating than its neighbors. Meaning that even if these 2 children have the same rating, as the second one gets 1 candy because its neighbors are not, it's not higher than its neighbors. And I tried to understand the thing, like the definition of neighbors. Is it the child coming before or after? So I tried to run my own input case with lots of the same duplicate numbers in the end, so it gave me this answer. You can also try yours by adding a test case and running it. Of course, it will give us an error, but at least we know the right output for this. So it gave me 8. So I tried to create its answer output array. The first child gets 2 candies. Second child gets 1, third gets 2, and the rest gets 1. Just like this one. So that gives us 8. Okay, so that was the part for understanding the question, and the one thing I noted is I take a note of this. Each child has at least 1 candy, higher rating, higher candy than neighbors. Neighbors meaning left and right, previous and next maybe. So now it's time to start the ideation part. You can think of, you can take a pen and paper and analyze the outputs, inputs. How can we get this answer? I'll be like, you will have a few minutes for that. So I'll be muting myself and doing ideation. Okay, I'm back. Let's get back to it. Let's do the recap of section 2, ideation. So the next steps I did were to writing conditions. There are basically 3 conditions. First one is the current number is smaller than its neighbors. In such a case, we are giving just one candies. For example, right here we have 0, it's smaller than both of its neighbors. We just give it one candy because at least candy we can give is just one. So the second condition, the current child's rating is bigger than its neighbors, than his neighbors actually. We give biggest neighbor plus 1 candy. We can see this, for example, right here, this one is bigger than one of its neighbors, like than one of the neighbors. It should be of the neighbors. Yeah, the biggest neighbor, next biggest neighbor actually, next biggest neighbor plus 1 candy. So it has, if we put, for example, if you put, I have an example here, we have 7, it's bigger than both of its neighbors. We will give it one more candy than 6. At the end, like I had this answer, so 6 had 2 candies, 7 should get 3, like one more than its biggest neighbor. And we have third condition where the number is the same as its neighbors. For example, this 2 has, both of its neighbors are the same, so we give it a 1 candy. Because like there are no neighbors bigger than less than 2, we just give it minimum 1 candy. So these 2 cases, if you can see, have the same output. Maybe we can handle them together. And for this case, we will need another condition. Let me just write it in a way. 3 and 2. Logically, I try to divide them in these 3 groups. These 2, we can have them together. Okay, then the next one, I try to come up with my case where it handles all the cases. For example, we have a number that's less than both of its neighbors, number that's higher than both of its neighbors, number in between, and I run it in the test case, so it's expecting 13. So the end result should look like this, or this array should be the output. How do we get to this one? The first thing I was thinking is like we need to check the neighbors. How can we check both of the neighbors at the same time? For example, if I take 1 and 2, it's easy. Like I compare 1 to 0 and it's bigger, so it should get more candy than 0. 0 should get at least 1. Pay attention to the at least 1. So meaning that initially we will give every children 1 candy, at least 1. So the first thing I checked was 1 and 0. 1 is bigger, so it should get bigger candy than the 0. Like I have these cases. Current is bigger than next. This is our case. I want to increment current to candies next plus 1. This one should get incremented if it's not already bigger than this one. I came up like with this condition at the end, and you will see why. The first thing that came to my mind was increment current to candies next plus 1. By candies, I mean this array, the one I created, and this is our children array. So I check the candies next. It's 1, it is equal, so I need to increment it. I incremented this 2. And the next time we have our current, this time will be 0. And the child we are checking it with, like next, is 2. Let me write current and next. So we are now comparing 0 and 2. In this case, 0 is less than 2. We have like 3 conditions. What should we do? If it is less than the next children, a next child. So we need to increment the next child by 1. Next candy or something here. Like first time we made it 2, now we are checking this 2 and it is bigger. Should we also check increment if not already bigger? I guess no, because it's our first iteration, so everything is 1, everything is either equal, so we just increment the next by 1 or current plus 1. And the next time we have 2 and 2. This time they are the same, so we have current and the next the same, so we just set next to 1, the lowest possible value. Okay, one more thing, smaller than the neighbors. Okay, so we set it to 1. We do not change right now, so we move on, and here we have the same case, they are the same, we just set the next to 1 and we check again, and the next iteration we have 2 and 6. 6 is bigger, next value is bigger, so if the next value is bigger, we just want to increment the next value. Let's increment it to by 1, like current candies by plus 1, and move on. We have 6 and 7. 6 is less than 7 again, and now here you can see why I said current candies plus 1 instead of saying just plus 1. If I did like 7 plus 1, it would end up at 2, so it should be, I should look at the candies table, see the value for 6 and then increment by 1. And at the end we have 7 and 2. 7 is less than 2, so we should increment the current, right, if we look at the first logic. But this is wrong, it's actually we should just skip. So we should increment the current candy next plus 1 only if candies the current, like only if here we have equality or this one is less. So for the first case we had both of them the same, so it works, we just increment the current. For the last case it also works because it checks these candies as a logic or condition, right? Candies condition. I just forgot to turn on our timer. Okay, so this was my logic basically. I feel like it works because we are updating both values. We are like looking at the 2 values at the same time. If one is bigger, we are updating, moving on, taking 2 numbers at the same time. Let's take some more examples. Let's take this example and try to run our logic. So we have this output input. We will have an array filled with 1s, and we take our logic. We first time we have 1 and 0. 1 current is bigger and the candies are the same, so increment 1 the candy 1. Okay, next we have 0 and 2. This time current is less than the next one, so we should increment next to candies current plus 1, which is incrementing is 2. Is this the right answer? Oh yes, this is the right answer, but do not forget that at the end we have to return the sum of these answers. So at the end I should return 13 for this case and 5 for this case. Maybe I will just loop through the array once more to get the sum. Is it possible to do it without this array? Okay, before that question, let's examine the time complexity of this. So if I write the pseudocode, we will loop and create array with ones or ones. and then we loop through both arrays at the same time, keeping this logic, like with this logic. Okay, and at the end we also use this sum of the list, which will also result in, like, I believe we will have n and n time complexity for both of them. Since we are doing, these are not nested loops, it will be something like n plus n plus n, which is 3n. Basically, like, we should drop the constants. As we are talking about like big O, we just drop the constants, it will be n. In the big numbers, it doesn't make like much difference. It's 3 on n or n. That's why we just drop the constants. We have big O of n time complexity. For space complexity, for this one, we again have big O of n, because we have this new array created. So for every incoming array, we have just new array created. For Candice array, as I called it, which has all the numbers inside the children array. Ratings array, actually, this one is ratings array. I just okay. So ratings array, meaning that we are creating extra linear space. And one thing I'm thinking is, like, can I do it without this array? Because we are only looping once. If this logic works, it seems like it's working. Let's see. How can we do it? For example, we have 1 and 0 at first. We know for sure that the default is 1. Okay, let's think about it. Like, every time we see next, Candice next is always 1, because we are iterating only once. So Candice next is not changed at the beginning, it's always 1. Candice, do we have, yeah, here we have Candice next plus 1. Okay, we need to take some extra minutes for this explanation. So Candice next plus 1. So this means we can do it 2. Okay, yeah, every time current is bigger, we increment it to 2. Or by 2, is that so? Is that the case? Like, every time, yeah. If this condition is met, we increment it by 2. Candice next, I replace it to 1, because, like, every time Candice next is 1, we have this empty array. We have not iterated through the Candice array, meaning that every time the next will be 1 until we change it. Okay. We have not used Candice next anywhere. Okay. If current is less than next, increment next to Candice current plus 1. Candice current plus, okay. We always need this Candice current value to work with it. Can we save it in a variable? Candice, something like just Candice current, which will start with 1. Or let's do 2 variables, Candice next and Candice current. Candice next will always be 1, starting at 1. Candice current will also be 1. We start with 2 1s. Let me remove this for a while. We have we want to get this to this array. Let me just remove it, but for now, let's go back. And here, let's start checking. So 1 and 0. 1 is bigger. 1 is bigger. Current is bigger than next. Increment current to 2 if Candy's current is less than or equal to 1. I can just say equal to 1. Candy's current, let me change it. Candy's current is Candy's current plus 1. Okay, Candy's current is actually 1, so we just increment it is to 2. Yeah. I just broke the logic right here. Is it less than 1? No, seems like this is working fine. We can say Candy's current. And here we have current plus 1. Okay. The first time we have Candy's next 1, Candy's current 1. We check 0 and 1. 1 is bigger, current is bigger, so increment current to 2, and this condition is met. So we have 2. We actually can have this sum, which will keep sum of the candies. So we are incrementing current to 2. Here we should add it to the sum, which and also here we should increment the current to 2, meaning that this one should be 2. And next we don't touch the next, but at the end of each step we change our values, like current becomes 1, like next, and current should be swapped. No, actually current should be dropped. Candy's next should be current. Is Candy's current sum plus equals Candy's current. Candy's next is Candy's current, and it's actually the reverse. Because when we move to the next 2 items, this one was our current, imagine, this one is our next. When we move, our next becomes current, and the next value is just 1. So Candy's next should be 1. Candy's current should be Candy's next. But we should do this assignment first so that we don't lose our Candy's next value in this assignment. And we also increment Candy's current right here before it gets reassigned for after each iteration. Okay, next iteration, so we put 2 here, and we actually do not need this. We have this sum. Sum is 2. Next iteration we have this time Candy's current is 1. Next is 1, sum is 2. So right now we have 1 and 0 and 2. 0 is less. We should increment next value to Candy's current plus 1. So the next value is this value. It should be incremented Candy's current plus 1, which will be 2. It will be 2, and we skip to the next one. We see we need to add Candy's current to our sum, which will be 3. Our Candy's current will be Candy's next. It will be 2, and Candy's next will be set to 1. Okay, now we are at this 2. So let me just have this pointer at the current. So we have 2 and 2. This time they are the same. We decrement next. No, we set the next to 1. It's actually at 1. We just reassign it to 1 and move on. We add Candy's current to our sum, which will be 5. Candy's next will becomes current, which will be 1, and this one is also 1. And right now we have these 2. They are also the same. We just set the next to 1, which is already 1. We add Candy's current to our sum, which will be 6. Candy's current becomes the next. No point in reassigning. It will be 1 and this will be 1, just so on. And we have 2. 2 is less than next. This condition increment next to Candy's current plus 1. Candy's current is 1, so increment next to 2 and add current to the sum, which will now be 7. Candy's current is next value is set to 1. And next we have 6. 6 is less than next, so we next increment the next. Candy's current plus 1 increments it next to 2 plus 1, which will be 3, and move on. And here we add Candy's current to the sum, which will be 9. We set it to the next value becomes 1. And at this point we have 7, and 7 is bigger than next. Increment current to 2 if Candy's equals to 1. Okay, so Candy's current is not equal to 1. Yeah, actually it's not equal to 1. Candy's current is bigger than 1, meaning that next is always 1, but okay, if they are equal we would increment, but here it's bigger. We don't increment, we don't do anything. But here we should add Candy's current to the sum, which will be 12. Candy's next will be current, and next will be 1, and we loop out of the array. One thing to note, I just noticed that we had this last value not added, like the 1 candy we are giving to the last child was not added because we moved out of the loop. Our previous value is out of the loop. That's why at the end of the loop, add it's actually sum plus equals current. Is it Candy's current? Because it becomes current, like it's sorted in here, and that should be it. Now it's time to code. You can code it yourself. I will again pause the video, and yeah, good luck. At the end, after like 10 minutes, I will be coming back and doing the recap for coding part.